Hey, in the last tutorial we made our stack dynamic just by calling this malloc function here in order to allocate the array dynamically with the size supplied to the init function, and then we also return the deallocate function in order to deallocate the array. Whenever the job is done, we can call this deallocate function in order to deallocate the stack. There should be a modification. The top should be taken back to -1 if the deallocation takes place, and also the size of the stack should be taken to 0. So we are done with the allocation and deallocation. Now we can make it more dynamic. When the stack is overflow, then instead of showing the message stack overflow and returning back to the caller, we can just grow the array to its double size by retaining the existing value, and that will make it more dynamic. So for that purpose, I am declaring a temp array, and again I am calling the malloc function to allocate the double of the current size. And here we should supply sp arrow size multiplied with 2, so that will allocate double of the current size, and we are assigning the return value, the base address of the allocated space, to the temp integer pointer. Now if this allocation fails, then indeed it's overflow. The system is unable to give us more memory, so we just can print the stack overflow and can return to the caller. Otherwise, the double sized array has been allocated. Now we can copy the existing content to that temp array. For that purpose, I'm declaring a variable I, and we should go on iterating from I equals to 0 to I less than equals to sp arrow top. That's the current location up to which the contents are kept in the stack object. So we should copy the ith element of the current item array to the temp array, so that this particular for loop is going to copy the content of the current item array to the temp array. Now we need to deallocate the existing item array. So for that purpose, I'm calling the free function. So the existing array gets deallocated. Now I am just assigning the temp to item again. So the item pointer is now going to point the newly allocated location that contains the existing elements as well. Now we need to double the size of the array. The size variable should be actually doubled. So we are done with the dynamically allocated stack. Now each time when the overflow takes place, the size of the stack will be actually doubled. Let me just write another function, get size, that's going to give us the size, current size of the array. On receiving the stack pointer, it's going to return the size of that particular stack. It should return sp arrow size. That's a small function. Okay, now let me go ahead and declare a stack. Now we have allocated this S1 with 3 elements, and I'll go on with pushing, and when the overflow occurs, it will be automatically doubled. That means 6 elements will be allocated automatically, retaining the existing 3 elements. I can just write a printf here to show you the current size. And we can call the get size and pass on the address of the current stack. Okay, now let me go ahead and run the program. So I'm pushing. You can see that size of the stack is currently 3 elements. I'm entering 10. 10 has been pushed. Again I'm pushing. It's still 3. 12. Again I'm pushing. 13. Again I'm pushing. You can see that the size of the array is now 6 element. So the stack has been doubled. Now let me push one more. Okay, now I'm popping. It's 15, 14, 13, 12, 10, and then underflow. So the existing value are retained in the stack. So now this stack is totally dynamic, and we can use this stack in some other program. These APIs, these functions, they are well developed, and we can use this in our programs wherever required. So in the next video, we are going to develop a program that's going to use this stack. Thank you.